All right, so we're going to start slowly here. Welcome, everybody. My name is Jonathan. We're going to all introduce ourselves, and we're even going to get to learn to know you guys. But before we start, really, I just want to make sure that everybody has cloned the repo. And then even if you clone the repo more than an hour ago, please do a git pull because we were still improving and tweaking things, improving slides and everything. We've built all this material just for you guys. So you're going to be the first ones to go through it, and yeah, we're continuing to improve it, and we've been continuing to improve it for the last few weeks. All right, so welcome everyone. My name again is Jonathan Rocher. I work at KBI Biopharma. I drive software engineering and digital innovation there, and we're super happy to have you guys. And we can go around. So we'll be four in this team to present this tutorial, and that's going to give actually a lot of space, a lot of manpower to help every one of you. We have lots of exercises throughout this tutorial, so please don't hesitate, raise your hands, and we're going to all be able to help you.
Hi, everybody. I'm Jason Chambliss. I actually work with Jonathan at KBI as a software developer. I'm the only one of the four up here that doesn't or hasn't ever worked at InThought. But I'll be up in the side here. If I'll be watching for hands. If anybody needs any help, just raise your hand. I'll come over.
Hey everyone, I'm Siddhant. I work at InThought right now as a scientific software developer, where I write code for, I build applications that are used by geoscientists. I've been at InThought for a couple of years now, and before that, I did my PhD at UT in computational science. Great to be here and be presenting this tutorial.
Hi everyone. I'm Prabhu Ramachandran. Sorry. I just finished another tutorial, had lunch and came in, so my voice is breaking up a bit. So I've been using InThought tool suite for many years now. I worked briefly with InThought for a couple of years, in 2013. But I've been using the InThought tool suite since 2005, roughly. And I've built several applications using some of the stuff that we're going to be teaching today. One of which, perhaps the longest lived, has been Mayavi, which is a 3D visualization package, which is built with the ETS, which is part of the ETS as well. So that's where I come from. But in my day job, I am a faculty member at IIT Bombay, and I'm an aerospace engineer. And my research is around computational fluid mechanics. Yeah, so glad to be here, and it's really nice to have worked together to build this material. I think it's exciting material because it covers a lot of ground. Some of the stuff even I don't know fully, but hopefully at the end of this you'll see, you may have to be a little patient initially. There are lots of concepts, lots of things, but at the end of it, at least we believe that there's that you will go away with a set of tools and a set of skills that will be very valuable. So thank you for being here.
All right, so in this tutorial, we're going to use an excuse for teaching you guys ETS, InThought Tool Suite, to build a desktop application. And so we're actually going to build this tool here in just under 3.5 hours. So I think that speaks to the power of the framework that we're going to be using and trying to put into your hands. And so without further ado, let's just give you guys a quick overview of the actually, before we go into the outline, I want to do a few questions with show of hands to get to know you guys better. So let me ask a few questions. How many people have been using Python for less than a year? 1. 1 to 5 years? Okay, and more than 5 years? Everybody else? Wow, that's awesome. Great. How many people build tools for academia? Okay, versus the private sector? It's the rest. Okay, so that's about even. That's great. And then, how many of you work in very small teams? I'd say less than 5 people dedicated to building a single tool. Okay, and so more than 5 people, 1 or 2. Okay. Okay, yeah. So most of you guys are building tools in small teams. That's been my case until very recently, also at KBI. Before KBI, actually, I was at Nthought as well. So that's how I got to know the Nthought tool suite. I've been using it since 2010. So we have a couple of decades of experience with Nthought tool suite here. It's gonna be great to share this. And yeah, at KBI, at first I was, developer number 1 or close to it, the only one doing full-time development of tools. And the power of ETS is to be able to empower very small teams. We're going to speak more to this, but small teams or fairly small teams to build tools very quickly. So we're going to try to build this in 3 hours. We've already, built it for you guys, but we're going to teach you to do it yourself. Any questions before we get started? Actually, another show of hand. Has everybody who has not cloned the ETS tutorial repo? You have not? So I'm going to bring it back. Here is the link for the tutorial. Sorry, it's inside my own space, so yeah, you got it. So please clone the repo real quick, and then in the README, there are instructions for creating. We should all have a dedicated Python environment that we can, mess around with for this tutorial. So we have instructions in the README for you guys to make sure that you have a Python environment for this. Okay, and then so while I'm going to speak to the outline, general outline, and then I'll let you Prabhu jump into the introduction. So just a quick outline of the 4 hours, 3.5 hours that we have together. We're going to give you a quick introduction to the Nthought tool suite. What it is, why use ETS? There are some good reasons, and even more specifically, when to use ETS. There are situations where ETS is going to shine and it's going to be great, but ETS is not for every digital solution out there. There are lots of problem sets that don't fall into the space that ETS solves. Okay, so we're going to introduce kind of some of the criteria to recognize what type of tools is ETS good for versus not. And then we're going to slowly build our application, and we're going to we are going to mainly present 3 packages to you guys, 3 packages within ETS that are going to allow us to build this application. So the first one's going to be traits. It's at the core of ETS, and it's going to allow you to have reactive programming. If you want to build a tool, it needs to react to events. So that's what traits does. It allows you to do reactive programming. Then we're going to build, Sedan's going to lead that second section and build views, UIs for your data using Traits UI. All right, so we're going to build some panels there, and then we're going to use PyFace as the third step to put it all together and build an application. If I go back to the title of this tutorial, actually, I'm not sure if this title was in the agenda or if it was something slightly different, but I feel like the most important word in this title is scalable. We're going to try and put into your hands tools that allow you to build something scalable. There are so many tools out there to build a tool that cannot grow. What we're presenting to you guys today is something that can scale. I've built many products for many companies using ETS, products that are worth lots of money. I've done that at Nthought. I've done that at KBI. These are tools that can grow, that can be maintained over time, that can scale to large and valuable scopes. Okay. So we're gonna put it all together with this PyFace package that has a framework in it to allow you to think of your applications in certain terms and start kind of offloading your responsibilities. All right. So as we're going to go along, and then we'll talk a little bit about packaging at the end and give you guys some pointers to wrap it all up. And as we're going to do this, if you've looked at the repository that we've given you guys, you'll see that there are lots of folders, stage 1, stage 2, stage 3, and so on and so forth. So we're basically all of these stages or all of the kind of, you can think of them as Git commits, right? We're building an application and we're just showing you the life of the application, starting from a bare script at stage 1 all the way to a fairly fancy application at stage 7, which we will probably, I doubt that we'll have time to cover stage 7, but we still gave it to you. If we can, that would be awesome. So, okay, with that, I'm going to leave it to Prabhu to introduce ETS. Oops. Yeah, sorry. Oh, I don't. Actually, do you want me to do a git pull? Okay, yeah, we're good. Here, Prabhu. Oh.
Oh, awesome. So I don't need this?
You don't.
Thank you. Thanks a lot. Oops. Shall I full screen it? Yeah. Can I make it a bit smaller? Yeah, I like that. Ouch. Why doesn't it go in full screen? I did. Oh, sorry. Okay, I guess that's okay. It's okay. Okay. All right, so let's jump right in. So all of this content that we have, in the repository, there's a directory called slides, which has, you've committed so it has both the IPython notebooks and Markdown files. We edit it usually in the Markdown and generate IPython notebooks. So you can feel free to, in fact, you're recommended that you follow along using Jupyter notebooks. So you should, if you're not familiar with this already, cd into that directory and do Jupyter space notebook on a console, or whatever your favorite way of starting Jupyter notebooks is in that directory. And then select, we've numbered the notebooks. So 0, 1 is just the intro, it's just blah, blah. And the second one is really where you're going to type along and follow, do some exercises and stuff like that. And after that, we probably will switch to using a mixture of the console, terminal, as well as using perhaps your favorite editor for the exercises. All right, so first steps, does everyone have the repository and all the installation instructions? Is there anyone here who does not have it and needs some help? Can you raise your hands, please? Awesome. Fantastic. I love this crowd. Okay. um, all right. So then I can skip this and we can jump right in. So why do we need a UI? This is one of the first questions, many Python programmers might think about. Do you really need an application, especially if you're used to programming, you're used to terminals? So it turns out certain tasks are obviously well done with just scripting, but there are lots of tasks that are much easier with the UI, especially those that have a lot of visual component, a lot of those where you have a whole bunch of options and you can't remember all the commands. It's a lot easier to drive these applications with a UI. The other major factor about UIs being useful is they're much easier for non-programmers. Sorry. And this, so it lowers the barriers for those who are not too comfortable doing the programming. And it also makes the application much easier to share. So I think most of you may have examples in your own lives where you have specific applications that are very well tuned and well designed to do specific tasks. And they will typically have a very carefully designed user interface. So user interface has to be done with some care, right? So you want to optimize a certain workflow that you're working with. So UIs are like great for things like this. And this is where we want to facilitate building UIs easier for scientists and engineers. That's kind of our emphasis. So first question again is, so okay, fine, we'll build a UI. So why do you want to do it with ETS? Why not just write it with Qt? The first thing is, of course, traits and ETS are not new toys and the new kids in the block. They've been around for a while. I think traits may have started 2004, 2003, something like that. They're all open source. They're fairly mature. And as Jonathan just said, we've all used traits to build a whole variety of applications. So it's not like, it's a new shiny little library that we've just built. And also that it's easy to start. So if you want to just build a small, tiny little UI just for some throwaway code, it's very easy to do with ETS. In fact, sometimes when I want to show off to a student saying why you should do Python, I start up a IPython console, and in 4 lines of code, I can show him a little UI. And they're like, oh, wow, you can do this with Python. So there is that, of course. But the more important thing is you can go from that point to building a very scalable application as well. So this is the nice thing that Traits UI, and this set of packages brings for you. And to do that, ETS actually, in some ways, forces you to rethink how you write your applications. Can't fully force you, of course, being Python and all, but it basically promotes the use of a model view controller kind of design, which we will probably touch upon more by practice rather than by theory. But the emphasis is basically to build reusable models and then associate a view with those in a very declarative way. That's kind of how you tend to build applications with ETS. And this kind of forces you to think about your application in a very different way. It forces you to think about, your what some people call business logic, or what some people call, your core models, and that promotes writing very scalable and reusable, testable code. So a lot of this comes from the fact that a lot of these applications are enterprise kind of applications that need to live longer than just an assignment or a throwaway piece of exploratory code. The other nice thing that the ETS tools afford is the fact that they are sort of back-end agnostic to some extent. So initially, ETS and traits were using the WX-Python toolkit. I don't know how many of you have heard of WX-Python? Not many. Okay, so there was a time before Qt where WX-Python was one of the front runners in terms of UI toolkits. But then since Qt has come along, WX-Python has sort of seen a decline. Even within ETS, I think Qt support is much better now than WX-Python. But ETS will work with either, with some pros and cons in each case. All right. The other thing is it interfaces very well with a set of other sister packages in the ETS universe, which facilitate plotting both in 2 dimensions and 3 dimensions. So this makes it possible to do scientific kind of application development, makes that possible with ETS. Yes, and again, reduce development costs, a single programming language, that's fine. Yeah, so okay, so it's all of this is going to be desktop side. None of this is going to be client server, none of that stuff. So the emphasis today is about building desktop applications, not for client server applications. All right, and so now the downsides. So the downsides are one of the biggest downside perhaps today, especially in this context with the web-based tools being very popular, is that we currently in ETS are limited by toolkits that are primarily desktop oriented. So Qt, WX Python. There is no clear-cut solution that we have for a web-based application. In principle, it's possible, but we don't yet have the infrastructure or the requirement internally to build something like this. We do have some libraries which allow you to take a Traits UI and give it a HTML-based user interface, something that's currently, I wrote this with some colleagues many years ago, but it's kind of in disuse. It's still not maintained very well because it's kind of a one-person project, weekend project. So no, this I'm talking about Jiganov. Yeah, which basically presents Traits UI as a JavaScript object model, and so using Tornado you can make an application which has a UI that kind of predates that. But the other project he's talking about is to build a SciPy widgets backend for Traits UI, which started, but it kind of petered out because SciPy widgets is not as featureful as Qt or WX Python is. It's not a full-fledged toolkit. So the natural downside of this is that all the applications you tend to build with ETS tend to be desktop applications, and that's not the solution for all kinds of problems, right? So you may want to have something that from the get-go has to have a web presence, in which case this may not be the right tool set. Having said that, I think if there were enough resources, it's something that's definitely doable. It's not doable, but I don't think Nthought has or anyone using ETS has actually had the resources or the requirements to build something like that. Okay, so what is ETS? So ETS is an open source set of tools. You can find this from the documentation here, and it has a whole bunch of packages. The first among these is Traits, because Traits is kind of the bedrock. It's kind of like NumPy being the bedrock of all scientific computing in Python ecosystem. In ETS, Traits is that bedrock. So all of the packages will use Traits and use Traits heavily, and they're written in a particular fashion that relies on the fact that you have Traits. And as a side note, what many people are not aware of is there's a library called Traitlets that is used in Jupyter notebooks. And that library actually has its origins in Traits. So it's a sort of simpler version of Traits, if you will, which doesn't have a C backend for performance reasons. Traits has a C backend as well for performance. But Traitlets doesn't have that, and it doesn't have a bunch of additional features. But Traitlets is based on Traits. The ideas came from Traits. Traits UI allows us to do easy UI building, which is basically declarative kind of UI building. So normally if you build a Qt application, you create the widgets and then you start wiring things and connecting things together. You don't have to do that with something. You barely ever need to write a Qt specific code. Then on top of this is a library called Envisage, which allows someone to build a plugin based application framework. So if you want a framework where you want people to be able to contribute plugins and things like that, you would use something like Envisage. But that's a bit advanced. More on the scientific side, if you're looking to do plots, there's a very powerful interactive and performant 2D plotting library called Chaco, which is Nthought, which is again part of ETS. It's again open source. Unfortunately, it's not as well used outside of Nthought and that environment. I don't know why, but I guess because Matplotlib is so good at producing publication quality plots. But Chaco does have a lot of powerful features, and it's really well suited for doing interactive plots. So if you notice, if you look at Matplotlib, so let's say you do a scatter plot, or not a scatter plot, if you do a histogram, and you want to update the data on the fly, it's a lot harder. Okay? It's not set up to be useful or efficient when you want to do updates on the fly. Chaco, on the other hand, is built from the ground up on top of traits, and it's fully reactive. So if you want to do like quick updates on plots, you'll use something like Chaco. Then there's Mayavi, which does 3D plotting, and again, it sits on top of traits. So again, you can embed 3D interactive visualization in your application using ETS. So this is a big selling point, the fact that you can do 2D plots and 3D plots. So a lot of Nthought applications tend to have this in them. The other thing that's pretty common when you want to do application development is you may have tasks that are long running and you don't want to interfere with your UI. So there's a traits futures package. I don't know if we'll have time to talk about it today. If we do, I think there's some content inside the slide set that we have about it. But what it allows you to do is it allows you to use a thread pool executor or a variety of executors that the concurrent.futures package offers. And it allows us to run computations on the background without blocking the application from running. So that is also part of the ETS tool suite so that you can build interactive applications as well, while doing some long-running computation. In addition, there are some others, but these are probably the most popular used packages in the ETS tool suite. And the way that this is set up is through a layered approach. So basically, we have Python, which is most of the time we are talking about desktop applications and we are talking about a CPython layer. And we may have applications which have extensions that are built in C or C++. For example, Qt is a great application, great library, implemented in C++, but then has Python wrappers. And then on top of this is like Pandas and traits, NumPy. And then on the UI side, we have PyQt or PySide, Qt or WX and WX Python. And then on top of that, there's PyFace, there's Traits UI, and then the sister packages like Mayavi and Chaco, TVTK, enable a whole bunch of these packages. And the goal is to get you comfortable enough that you kind of see the core pieces here and the core building block ideas so that you can use any of these, mix and match, and build your application sitting on top of this framework. And that's the goal of this tutorial. Okay, so just to showcase and give you some examples, Jonathan already showed you the screenshot of the application we'll be building today. But you can also do other kind of applications. So I've put together just a few simple ones. So here's a little dialog which has a 3D visualization with some sliders here and some text fields where you can edit and put stuff. You can write all of this in pure Python without a single line of Qt or WX Python code. That's the nice thing about this. And this application is about 130 lines of pure Python. That's it. So you can basically create something as rich as this with all of the features that are available with very little code. Another case is, so this is a case that is, okay, I'm going to make this a bit smaller. Okay, I guess you can see to some extent what this is. So this is an application that's this is something that I use for my research. I do particle-based computations, and we generate a bunch of files, and you want a visualizer for this, right? You're generating output, you want to quickly be able to visualize and then explore the data that's being generated. So I wrote this application, again, pure Python, using ETS and Mayavi, and you can put together a fairly sophisticated application with a whole fancy UI without spending a lot of effort. That's the kind of power that you get with ETS. Okay, so so we'll start with a simple Python script. That's where we're going to start. The details of this Python script is not important. So some of you may not be familiar or may not come from an image processing background. So don't worry about the details. That's the reason we give you that basic scaffolding code. The goal is to see, okay, given that you have this code, we want to make it into a nice application, a scalable application. So we're going to start with the script which detects faces, and it also extracts some metadata from the images. Okay. So let's say we found PIL or matplotlib, and we know, hey, I can make this plot. I can extract the EXIF information from these images. And now we want to say, okay, I want to build a image processing, not an image, or an image viewing library, which is customized to what we want to do. Okay, so that's the application we have in mind. And this entire tutorial is built around building this application. So there are many things that we could have done. We could have shown you a bunch of other things. But the way we have tailored this tutorial is to make sure that we are sort of giving you all the basic pieces in order to build that final application. Okay, that's what we're trying to do here. And we want it to be an easy to use UI. We want explicitly a user interface. And we want to write it in a way that it's scalable. We want from the get-go not to be a throwaway application. We want something to be scalable. And finally, we'd like to share this application. So I don't think we wanted to make an installer at the end of it, but I don't know if that piece works yet. But what we will do is we will give you the scaffolding so that you know how to set up a full-fledged project with a setup.py so that you could either put it up on PyPy or ship it as a tarball or something like that, or build a wheel from it and then ship it and share it with friends. So those things are possible. Okay, so I'm skipping this. You've already seen the resulting application that's going to be shown. So this is the schedule of what we're going to be doing. We're going to start with a simple Python script. Now, we're not going to explain the gory details of that script. I think it just uses PIL and matplotlib to do something. I don't know what it does for the face detection. skimage. It does uses skimage for that? Yeah, so we use scikit image to detect some faces, and that's it. So that you can treat that as a black box. You can look at the script. You can feel free to modify it as well. So what we're going to do is we'll start there from a throwaway script, a literally throwaway script, clean it up using traits. Okay, that's going to be our starting point. And to do this, we're going to have to spend some time learning traits. So we'll throw in some toy examples that you can play with, and some toy exercises so that you're familiar with the traits model. And as you've seen, traits is like the bedrock of all of this. So it's good to understand that. And once we do that, we'll build a basic user interface for this little thing simple image viewer that we have. We'll build that and put in matplotlib as well. So we'll show you how you can use matplotlib to make a little plot into this simple user interface. So that's going to be the first phase, and we'll do that using traits UI. So you'll do it in a declarative fashion. No Qt, no WXPy. And then we step into the process of taking this still at a throwaway script level with with a little bit of cleanliness. We're going to make it suitable to be written out as an application, as a full-fledged application. And we'll introduce PyFace at that point. And then start building more features, menus, and things like that to it. And then if there's time, we'll do optional features like traits futures or packaging and things like that. Okay. So that's the schedule. So the basic script is already there in the repository. If you go to stage 1, there'll be a single script there. You can run it. What it does is it detects faces in a given image. Can I get a terminal?
So let's make sure
Okay, no. Oops. Just single terminal so I can increase the font size.
Yeah, come on.
Okay, sure. Awesome.
Somebody is trying to run the script and it doesn't run, let us know, we can come and help.
So I'm currently in the ETS tutorial repository. I'm just going to do, oops, sorry.
Could you make it a little bigger maybe?
Yeah, this is our script. As you see, there's not even functions. It's just it's like throwaway code. I'm going to just run it. Okay, so this is what it does. This is pretty much, oops. So if you remember the screenshot that Jonathan showed, he had exactly the same matplotlib figure, but embedded in a larger application. So all this has is just that matplotlib plot. Okay, so the application we're going to build is going to have a lot more than just that. So we'll probably have a file browser. You can click on different images. So it'll do all of that for us. But this is the starting point. Oh, okay.
Two images showing up, one with faces and one with no faces.
Yeah.
Who's not getting those images?
Jonathan, here.
You just can't find the path. So I'm not sure if this matters, but there's double. So I'm trying it on my own here with this. See what happens. Yeah, this is me. I'm just trying. I'm just trying to see if we can find it. So this is what's happening. Sorry, I would run it. I just can't find those images, even when I do have them. I think, yeah. I opened the directory higher. Oh, no. Tutorial. Is that? Yeah. Yeah.
Because it's a relative path.
Yeah.
So the paths in that script are relative, so you need to be in the right directory to run it.
I'll run it like not.
Okay. Okay, so okay, more people. All right, so I guess everyone saw the image detection. However good or bad it was, it doesn't matter. So the idea is, even though you're using SK image now, you could obviously use something more sophisticated later on, because that's now just a detail. What we are looking for is, building that application, which kind of tells you why this is important to design from the get-go in a clean way. That the detail of the computation is not the focus at this point. Okay? So if you have ideas or ways to improve that face detection, go for it. That's fine.
And actually, the name is called PyCasa because both Prabhu and I were missing the Big Casa application that Google built when they
Yes.
buying it. It was a great processing application. So anyway, so this is a joke, but
Yeah.
that was a dream of reviving this application.
Yeah. PyCasa. Okay. So so the next step is starting from here, we're going to learn about traits, and this is going to be sort of a detour in some sense. And some of the things you're going to be taught in that part is maybe going to be, why are we doing this now? But just be a little patient, because the things that we introduce there will be used later on when we build the application. And the goal that we're going to go for, not in the next immediate slide, is to build a clean model using traits. Okay? So the first step is going to be to extract what we think as a good model from this little script, build that out with traits, and then start building a UI on top of that. Okay. Oh, it already opened it. Okay. Sure. So you can go ahead and open the 02 traits.ipynb on your Jupyter notebooks. And you can just follow along as we do this. Okay. Okay, do I need to wait, Siddhant? Do I need to wait or? Okay.
Is it also path dependent to where I install? No. It's weird because I try to run it now and now it doesn't find packages. So I'm reinstalling, I guess, just to see it. I'll reactivate it once this is done. Okay. Hopefully that should happen. Okay, got it.
Jonathan, just let me know when I should start. Okay. All right. So let's get started with traits. So you can think of traits as kind of Python attributes on steroids. That's what I used to call it in the past. So you're all familiar with attributes on a Python object, right? You can think of traits as being attributes, but which have a bunch of additional features. The first is that these attributes can be typed. So we're used to Python objects having any type, right? You have an attribute. Attribute can be anything. It could be a string, it could be a float, it could be anything. But with traits, you can actually constrain it and make it a typed attribute. So you can say this is an integer, and if it is declared as such, if you assign it a string, it's going to complain to you. So traits allows you to have typed attributes. It is reactive in that if you change that attribute, you can listen to changes to an attribute. You can explicitly listen, or you could define what are called static handlers, where when you change that attribute, it will call back a function. Okay, and it's very easy to do this. They can also be observed, which means it's part of the same reactivity, that you can observe a trait on a specific object and react to that. Okay, we'll show you how this can be done. And this sort of leads to much cleaner code. And from the get-go, because you have typed attributes, a lot of mistakes, there are a bunch of mistakes that reduce because obviously these attributes can't be anything. Okay? And because we have declared the attributes with specific types, it also becomes easier to generate a UI. So there's machinery in Traits UI that uses this information about what every attribute is and can therefore automatically make a user interface for large part. And you can configure this using declarative approaches, which we'll look at soon. There's a pretty solid amount of documentation for traits, especially for traits. Traits UI maybe not as much as traits, but there are lots of, there is reasonable documentation. There's also a tutorial that you can follow, which goes building an application using traits and traits UI. So there is documentation, you can check it out. Okay, all right, so why all of this? Why do we need to do traits? Why can't we just stick with Python objects? Well, you win something by doing this, and it's not a lot of work. It's a change in how you think, but it's worthwhile because it gives you a lot of big benefits you get at the end of it. So just bear with us for a little while. All right, I'm going to skip that. We've already done this. So basically, a recap of that, you can do initialization. So when you normally create a Python class, you'd probably define in dunder init dunder, and then you'll give it a bunch of keyword arguments, and those become your defaults, right? Whereas with traits, it's much easier to do this. You'll start seeing examples very soon. So you can initialize things with default values very easily with traits. Validation is fully possible because you have every attribute can be typed. You can do deferral and delegation. So you can say this attribute on this object is going to be deferred to another object. And this is something that can be done with traits very easily. You can do notification. Again, there's reactive programming, and there's also visualization that comes for free. So let's get started. So this is our, I would say, a canonical example of traits. Okay. So pardon the example. Some of them are very simplistic and very silly, but they're trying to just illustrate a specific feature of traits. So we start with the following. All imports typically in an ETS package will have this structure of from package name dot API. Very rarely will we have from package name dot something else import something, right? Usually it's going to be from traits dot API import this, from traits UI dot API import something. So traits dot API import a few of these. There's delegate. Each of these is a trait, okay? Except this perhaps. Has strict traits is the base class from which we will inherit. So is everyone here familiar with basics of object-oriented programming with Python? Is anyone not familiar with object-oriented programming with Python? Okay, great. Okay. That I hadn't thought about that, but that is scary if someone didn't know this. Okay. So each of these instance int str are traits. We'll talk about this in a little while. And this observe is used to attach to observe a specific trait and react to that. Okay, that's where it's used. Okay. So the simplest class that you can think of, well, you can think of a simpler one, with a single attribute. Here is class parent. Okay. The parent has a last name, and the last name is a string, as you can see. So you can read this literally, and it kind of reads quite easily. Parent has strict traits, and there's a last name trait whose default is empty. It's just the empty string. Okay. And then we have a child, which also has strict traits, which has an age, which is an integer. Now you can question me, why should it be an integer? Why not a floating point number? Well, we can do that too, but for now it's an integer. Then the child has a father in this case, which is an instance of a parent. Again, you can read it off and it makes sense, right? And then the last name is delegated to the father. So the last name of the child is delegated to the father. Very patriarchal, I'm sorry, but it's just an example. The notification here again is illustrated by a very simple use. This is something that you'll see in a lot of existing traits code. Some code doesn't use this approach, but this is what's called a static handler. So this is a method, and the name here has significance. The underscore age underscore changed is like this magic method. If you define this, it's a method, so self is the first argument. You can have an old and a new, okay? And this is just printing that age changed from old to new. So what this does is, whenever the age attribute, the age trait changes, it'll call this function automatically for you, okay? So this is an indication of how you can do notification. So I'm going to just run these two, and I urge you to do the same on your notebooks. Hopefully it runs. And now I'm going to instantiate this and show you various features about this. You have a question? Oh yes, it's 02 traits.ipynb inside the slides folder. Oh, inside the slides. Yeah. So all of this is in the slides folder. Just Jupyter Notebook inside there, and then you should be able to run all of these.
One more Git tool maybe if you don't find it.
Yeah, if you did a Git, if you are a good student and did the
No, they were good students.
yeah, be a bad instruction.
Does anyone need help with a Git pull? Does anyone not know what a Git pull is? Fine.
Anyone having issues with that? So this isn't okay. It's in slides. Ah. Yeah, you had bad instructors. Oh, I did something I shouldn't have. Okay, does everyone have this running? Okay, so now what we do is we just instantiate these, and notice we didn't have to write an dunder init dunder at all. So traits basically takes care of that for us. So we're just instantiating Joe as parent. Joe dot last name is Johnson, but I could have also done this. I could say so I could have done this as well. I'm sorry, I'm struggling with this keyboard. So what we've done here is we've created a parent whose last name is Jason, and then we changed this back to Johnson. I'm just showing you there are different ways that you could have done this. And then we have a child called Mo, and Mo's father is set to Joe. So we could have also done this. I could have said, you could also do this. So notice that we didn't have to write an init method explicitly. But okay, so now the first thing we're going to show you is delegation, perhaps not in the same order that we described them. Notice that Mo's last name inherits directly from the parent. So if I change the parent's last name, it would basically just reflect automatically. I don't have to do anything about that. The other thing is notification. So if I change Mo's age to 10, it'll tell me that the age changed from 0 to 10. And all it's doing is calling that method automatically for us. And here's an example of the validation. So if I now set Mo's age to a string, it's going to complain. Okay. Siddhant, you have some weirdness in your. If I hit escape, it goes into some edit mode. Sorry?
It's called Vim key bindings.
Ah, okay. Vim key bindings. Okay.
So
And why doesn't it scroll?
I think this is.
Oh, okay. I
Yeah,
have configuration options. Okay, it's fine.
Yeah.
Because. What is this one? Without the slides? Okay. No, so on mine, I've set it up so it will scroll for me. So if I can just scroll down. Yeah, super slow. And go fast. Sorry. Okay, so I guess you must have seen this error message. I couldn't scroll on the other one. So you can see it gives me a message saying age trait of a child instance must be an integer, but a string was passed. So the validation is kind of helpful when you run into problems. And the final feature is like really nice, which is I get this UI for free. I did nothing. I just did configure traits, and it automatically made a Qt based UI for me. So this is really nice. But what makes this more fun is the fact that if I turn on Qt interactive workflow on a Jupyter Notebook, if you do this, what Jupyter Notebook does is it sets up a Qt interactive loop so that I can create Qt widgets and interact with them live. Okay. And now if I did this, yeah, how do I bring it over? don't know. I think it's on full screen. Full screen, okay.
Yeah. Now you can bring it.
Hang on, I'm going to just shut off the header, shut off the toolbar. Okay. Okay, it's right here. Okay, great. Okay, so now I'm going to show you something interesting. I'm going to change the age of Mo here. Notice that the UI changed live automatically. I didn't have to do any wiring because the Traits UI automatically hooks into any trait changes on the object and it'll update the UI. So this makes it very easy to create a user interface which has a lot of these very cool features built in. You don't have to do much more. You don't have to wire those things yourself. So this is like a major selling point for me because, or for most of us, because we don't have to worry about updating something that's built on a Traits UI. We just change the object and everything reflects automatically. So that's a very convenient feature. Right, so with that basic start, the next thing is, okay, what if? So what if, well, you want to still do something in dunder init. The way we would suggest that you do that is you define a dunder init and make sure that you call super. And the way that the pattern that is used for all traits is that you always are given a keyword argument list of all possible traits that someone may have set. And you just pass that along to has strict traits init, and that's it. And then you can do whatever you want inside the init. So if you really want to create an init, you may do so. But the beauty of the traits approach is that you don't have to create the init. So the instant you define those traits, you're done. So basically, your classes look much easier, they look much nicer, and they're easier to write. So there are a bunch of predefined trait types. There is like a whole host. This is just a small subset of them. There's like booleans, complex numbers, integers, floats, strings, tuples, lists, dictionaries, sets, range. So range is like constrained kind of numbers. You can have constrained ints, constrained floats. You can do regular expressions. You can have things that are read-only, which means people can't change that. A whole bunch of others. Okay, so and we'll talk about some of these. We'll show you simple throwaway examples for these that you can use to learn traits a little bit. Oops, this should be has strict traits versus has traits. Oh, sorry. All right, so you'll see a lot of code out there that uses what's called has traits and not has strict traits. There's an important difference between the two, and we feel that you should use has strict traits because if you just define a class that uses has traits, you can add any additional pure Python attributes willy-nilly. As in, you can just say, okay, object dot some crazy attribute equal to something else that no longer has the nice properties of traits. And sometimes this leads to errors because you're typing, you made a typo, and you thought you're doing something to one of the traits that you have, but that it's a typo, right? So it catches those because the instant you're doing one of those, you'll get either an attribute error, or if it's a trait that you're trying to assign, you'll actually get a trait error. Okay. So it catches errors, and it will not allow you to set any attribute you have not declared. So which means you're kind of being honest to your own object model. So you've created an object which has certain traits. You're not going to introduce anything new inside a method, for example. So it kind of makes it, forces better documentation, if you will. All right, so let's move on and let's look at the first very powerful feature that traits offers, which is observable. The fact that you can observe any trait change. So here's the same example that we had before. We had parent, last name, we have child, age is an int, and father is instance of parent. We have the static handler here, where you don't need to apply any decorator like this observe. But let's say you have another method where you say, look, if the father's last name changes, I want to be notified. So you can do that by creating a method here. And the observe has this interesting syntax where you give it either a trait, and this is called an extended trait name syntax. So here you're saying, if the father trait's last name changes, notify and call this attribute, call this function. Okay. So and this function name has no, there's no requirement of it to have a specific name. It can be any method name. Okay. unlike age change, which has to be underscore age underscore changed, this can be anything. So this will always be passed an event. So whenever you use observe, the pattern is you will be passed an event, and there are different kinds of events depending on what kind of a trait was changed, and we'll talk about this in a short while. So in this case, you will get what's called a trait change event. Okay, and that will have a bunch of methods. A bunch of traits that you can look at. We'll look at that in a short while. So I'm just going to run this, and here is our dad. Last name is Zubi Zareta. Brownie points for anyone who knows who that is. And child is, okay, the father is dad. And now notice that it says the father's name changed to Zubi Zareta. That was because I passed Zubi Zareta as the name. Now I changed it to Valderrama, and the father's name changed to Valderrama. So notice that even though I changed the parent object's last name, I got notified. So this is like a quick example of how you would use the observe, the observe function, the decorator, in order to be notified. So again, a recap. There are these two things here. First is, why is that doing this? Okay. Is the static trait change handlers, which is trait name underscore changed. And the other is a decorator-based approach, which could work with any function, any method that you have. And this has this extended trait name syntax. And if you want to learn more about the names possible, yes? Yes, please.
If I wanted to hook up to more than one trait,
Yes.
would I do two decorators, a list? How
Great
would I
question.
pass that in?
Great question. I have an example a little later that does that. But the idea here is you just say, age, for example. So this will listen to both age on the object as well as father's last name.
And notice that the comma is
Inside the string, yeah. Does it support the bracket? I can give it a list of strings. It used to be there with, not for observe, okay. So my problem is I've carried along knowledge from 2005. So I'm a bit messed up with some of the new syntax, but that's why I keep looking there to make sure I'm not saying something wrong. But yes, that's easy to do. You can do a lot more fancy things. There's something else I'll talk about very soon. So for example, if you have a list and you have an item changing inside the list, you can actually get notified of that. Thanks for a great question. Yes, yes, yes. All right. Okay, we have the first exercise. I think we can skip this exercise and move on. We're running short on time. But I'll just go through this so that we want to modify the first example to produce this one. It's already done, so it's okay. We want to add a Boolean trait to specify, no, I changed this. And I didn't change this, I'm sorry. Add a bool trait and add an enum. So I'm going to just forget about this description here. I'm just going to walk over the solution and explain what this does. Okay. So we have a parent whose last name, same old parent. We have a child, same int, age int, father is instance of parent. We've added a first name to the child. That's a string. We have I guess a running joke here. Does the child like queso? And it's a Boolean. So bool traits can have a default value of true or false. So in this case, the child likes queso. And we've handedness. Is the child left-handed or right-handed? Okay, so we have an enum. So an enum can have any number of possible options. Okay, left-handed, has no hands, whatever it is. Okay, so basically you can have any number of possible string options in this case. And yes, setting a value to a handedness to something else that's not specified here is an error. So you will get an exception if that happens. Yeah, so that's the example. So we've just introduced two new traits here, bool and enum. Nothing much else here. Yeah, so again, even though we've introduced new traits, the nice thing is the dunder init, we don't have to do anything, no extra work for that. You can pass optionally any kind of traits that you've defined on as part of the constructor. Okay. All right. Okay. So now let's get more into events. So I said that whenever you have this method, a method that's being observed, or rather, you have a trait that's being observed and there's a handler defined as a method, you're always passed an event, right? So let's look at that. So in this particular case, the event that you will get back is a trait change event, okay? It's an instance of a trait change event. Okay? So here's an example that walks you through that. Everything is the same as before. I've just changed the dad name updated to show you the different attributes that the event has. So it has the following. Trait change event instances have an object, they have a name, they have the old and the new values. So the object is the object on which the trait was changed. Okay, so this might be useful in some cases. You want to know which object was changed. The second is the name of the trait. So in this case, it will be last name. The event.old will be the old value, event.new will be the new value. Okay, so this makes it convenient. So let's do this. Yeah, so notice it says age changed from 0 to 21. Main.child object, that's the object. Father trait was changed from none to the main parent object. Okay, and then the dad name was changed to the, yeah, that's the next print statement. Okay, so now if I change the dad's last name, it says main.parent object, last name, Ray Ahmed. Okay, so basically it tells you that these are all attributes of the trait change event that you can use. And there are many cases where you don't really need the event, but you have to pass it anyway mandatorily. But there are lots of cases when you say, I want to know the old value. If the old value was this, do that, you can write your handler however you want. Okay? But this is just a pattern that is worthwhile knowing about. Okay, so any questions at this point? Or should I just roll along? Okay.
I have a question for the audience.
Want a break?
We created an enum and we created a bool attribute. So if we were to call edit traits or configure traits on those, can you guess what would be the widget that would show up for these two things? A boolean and an enum? For the boolean, what? The checkbox, very good. And then for the enum? A little drop down. That's it. Thank you.
What did I do? Sorry. Oh, that's the parent, so I need to edit the child. Yeah. And that's a checkbox and that's a drop down. Okay. Moving on. So the next thing we're looking at is container traits. And these are very powerful. You can do a lot of neat things with them. So I'm going to talk mostly about trait lists at this point, and the rest is an exercise for you to look at. So here's an example, like again a silly toy example. We have a bowl of fruits. Okay, so the bowl has strict traits, and it has fruits, which is a list of str. So we're introducing the list. So notice that you can constrain not just the fact that fruits is a list, but you can also constrain what it contains. In this case, just strings. If you don't give it anything, you just say list, it can contain anything. Right? You're not constraining the type of what goes in. And now there is something interesting with lists, is the fact that you can change it in two ways. You can either set the entire list. So you can say fruits, object.fruits is equal to some list of strings. That's one way. The other way is to say, look, append or remove, because it's a list, right? You can mutate that list. So there are two ways to check for notifications of this kind. They are very different kinds of notifications. And so if you're just looking for changes, if someone just changed the list as a whole, you just do the same observe fruits, okay? Or you use the static handler underscore fruits underscore changed. And then you'll get a trait change event, which just has the information about what was the old list, what is the new list. Is that okay? So this is just a trait change event. Okay. On the other hand, if you want to know if the specific item inside that list was changed, you can do the fruits.items. Okay. And what this will do is it will give you a trait list event. So that's what this is going to illustrate. So let's just create this. I'm going to create a empty bowl. And now the first thing it's going to do is create, clobber that list with a new list, with just an apple, in which case it will call this. And the second one, it should call this. Let's see what it does. What did I do wrong?
It's the initialization. It's not.
No.
It's just the first one.
No, it's the fact that when you do fruits.items, I think I should do fruits:'items, is it? Yes.
So if you do fruits.item, it's
So-
going to get triggered if fruits changes
And if the
any
item
of its items
changes. Okay, so this was seen earlier as well. I didn't talk about it then because earlier when we defined father.lastname, if you notice it printed two lines, one where the child's father changed and the next where the child's father's last name changed. I didn't talk about it at that point, but okay, now we have to bite that bullet. So when you do fruits.items, it will listen for both changes to the fruits as well as fruits of items. When you do fruits:'items, it's just going to look for the items change. So let's try this now. Yes, and that works. So first, the list was updated. That's this. And the second was fruits, the items alone was updated. So notice that here, you can actually find out what was changed and where it was changed. So it'll tell you what was added, what was removed, and at which location in that list it was changed. So it's kind of powerful way to look for changes inside a specific list. There are other trait change events. There's a dict change events. So I urge you to write your own little example with dictionaries as well as sets as well. Okay, but we're not going to look at that. There are some more useful traits, and these specifically will apply to our little exercise, our application Picasa, because we have a directory of images, right? So we have files and directories. So it turns out there are two traits for this as well. On the face of it, they look very simple because it doesn't really do any validation to check if the given directory name is valid or not. That is on you. But what it does help us is with the visualization. So if you create something which has a file and a folder, when you create the automatic visualization, the UI element that's used for that will be an appropriate element. Okay? So right now it doesn't do anything fancy, but I'm just telling you that these exist. So here's a tiny example which shows you how to use dictionaries, directories, and files. Again, straightforward. So we have root is a directory, and we have a list of files in this, and we have a sizes, which is a dictionary in this case. Okay. So let's do a walkthrough of this. The dictionary can have any keys or values in this case. Okay. There's no constraints. So dictionary can have anything, just like a Python dictionary. But if you want to apply constraints, you can also use the keyword arguments key trait and the value trait. And notice that the value trait can take a nested dictionary, which itself has constraints of strings and integers. So what I have here is a simple object called a folder, which has a root directory, and it has a collection of files inside that, and it has a sizes, which is a dictionary. For every file, it has, so the key is for every directory, for every file, there's a key, and there's a dictionary corresponding to that, having a set of strings and integers. So in this case, it's sizes. So it's just going to have size as the key and integers. So I just showed this as a simple example of, with just like 4 lines, you can have a fairly interesting set of constraint types that you can enforce on your data object. Okay. So for example, if you look at this, and so now if I were to say f dot sizes, I'm really struggling with this keyboard. No, it's fine. It's my problem. So So notice it's actually going to complain. Even though I've passed it a dictionary and the key is string, that's okay, but the value is not a dictionary. Okay, and even if I were to make this a dictionary and say one something, it's going to complain because now this is not the right dictionary. So if instead I'd made this, now that's okay. So you see the power of this, that you can actually constrain the types. It makes it easy for you to debug issues, if your dictionaries aren't set right or whatever. Okay, so now we have a little exercise. I think we should do this exercise, which is modify the above example so that when you set the root directory, it finds all the files in that directory and then the file sizes for each of those and then sets the appropriate traits internally. It seems complicated, but the hint is use os listdir to list the directory. You can assume that the directory given is a reasonable directory. And use os.path.getSize. If you give it a file name, it will actually give you the size of that file. So use this to just build the, so add a method so that whenever you change the root, it will automatically fill up the files and the sizes. So 5 minutes for this? Okay. So we'll come around if you need help. And maybe after 3 minutes, I will start typing this. I didn't want to forget my laptop. Yeah. I can turn off the Vim bindings. Yeah. I use Vim, but I'm not used to it in the Jupyter mode.
If you press escape and then you can do JK.
Oh, I don't use JK even when I use Vim.
So do you want me to turn it off?
Yeah, please. I'd appreciate it.
Should be
Edit sheet, keyboard shortcuts.
this is probably extensions.
That's fine. Then leave it. It's okay. I've now started getting the hang of it. The other problem is I have a full keyboard. So I'm always in a mess when I go to another keyboard. So I'm typing XS instead of CD. But it's okay. Should I start the solution or another minute?
I'd like to suggest that you guys use the observe syntax because that's the newer way. Prabhu is an old hat. But the observe is the newer way, and the one with the underscore name underscore change is on its way out apparently. I think the observe is more powerful. So try with that one. And that's the one we'll keep using for the rest of the tutorial. We'll get familiar with it.
should switch to my. Sorry. I have the cell phone. Sorry. Yeah, HDMI is fine. Oh, I do need to pull though. Because I still am. For some reason, I'm not getting editor. Oh, yeah, it is. No, it is. It is. It's not. Awesome. Oh. Oh, it's all on main, right? Main. Yes. Okay. Oh, I didn't import directory. Okay, so I'm going to quickly try a solution here. I don't know. I think there's an option to os.lister to give me the full path, but being a bit pedantic. So, yeah. Okay, I don't even need this. Yeah, it's okay. I'll just leave it. Sizes is. Oh, this is the hard one. think that should do. So if I say F is folder, oops. It worked. Oh yes. Haha. Okay, it didn't work. So I did something wrong. Yes. So I made so it tells me exactly what I goofed up here. So notice that sizes should be file name and then a dictionary with a string and I just put a dictionary with just an integer here. So this should really be size colon this. So I'll just walk you through the error. It's saying each value of the sizes trait of a folder instance must be a dictionary with keys, which are string, and with values, which are an integer. So I just set sizes to a dictionary, which is just keys, strings, and values are integers. That's not what I want. And that worked. So let me.
Could you make it bigger?
Yes. Oh, sorry. Very sorry. Is that big enough? Okay. Okay, so it has all of these and sizes has all of this. So again, this is just some. But I guess you get the idea, right? That you can. The only thing we've done that is Traits UI specific here is to use this method, and the new is the new value of the object, the /tmp or whatever it is. And the nice thing here is, if I were to now say f dot root is /home Prabhu, now immediately it will automatically set up the rest of the traits. So this is the nice thing about the folder object. Now that I've created this object, whenever I change the root, it is going to make sure that the rest of the traits are up to date. So this is kind of reactive programming approach. So if you have an object that listens to changes and does what you expect it to do, right, then it's very easy to start composing things together and have them interact in a very specific way. And notice that here there's no UI. There's just simple Python object stuff. There's no UI coming in. There's no. You're just focusing on an object model that does something specific. Is any of this kind of unclear? If you want me to go through something, I'm happy to explain it. I'm just using list comprehensions.
I guess I have a general question.
Yes.
What would be the advantage of observing root versus
The static.
when you have something like just printing whenever it's changed or something like that? Is there a trade-off? Is there an advantage? When would you use one versus the other? Maybe?
The observe versus the root change, the static handler. I think the static handlers get wired first, and then the observers are added on top, but that's an implementation detail that you shouldn't rely on. But in principle, there's no real difference. It's just that the syntax is slightly different. The observe syntax is actually a bit cleaner because it gives you an event object. Whereas here, there's a bit of magic going on in that there are many ways you can define the underscore root changed. So if you do root change with no arguments, it will work. You won't get any arguments. If you give it a single argument, like new in this case, you'll get the latest value. If you do old comma new, you'll get old and new. So the problem is there's this implicit, I remember this because I've done it so many times, but it's a pain for someone who's new. So supposing you give it 3 arguments, will it give you name, old new, or is it name, new, old? So that's a pain point. Whereas if you use the event observer, it's like you get an event dot new, event dot. So it's a little easier if you're writing it for the first time. So this is just my old habits showing. But usually you want the latest value, in which case, just writing a static handler just works. So. And I personally like the static handlers because I don't have to think about what to call this name, the method name. If it is root, the name of the method is root underscore changed. Otherwise, I have to think, okay, root changed, I'll put some name, there'll be no consistency. Here I'm forced, that consistency is forced on me. So I like that a bit. But I think the modern way of using it is to use observe and do whatever you feel is appropriate. Okay, so the next important thing that we're going to need, even though you may think it's maybe not that important, but we're going to use this later. Supposing you have a quantity that is computed, and let's say it's a computation that takes a while. There's a toy example we have here, which is truly a toy. It's not doing anything important. Sometimes so for example, let's look at this example, we'll make it easier. So we have a circle, and the circle has the only property that the circle has is a radius. The area of the circle is not an independent quantity, right? It depends directly on the radius. Now, it doesn't make sense to say, okay, circle has a radius, but then it has another area which is also a floating point number. Because it doesn't make sense for a user to think about changing the area independent of the radius. The area has no meaning outside of the radius. So if that's your object model, you can always argue that maybe the area is the more important quantity and the radius is secondary. But let's say the situation is that you only care about the radius. So in this case, area should really be a property. It should never be explicitly stored. You can just compute it. So you could just do the following. If I just remove that, I say get underscore get area, and I declare area as a property. This would become a property which you can just, so it will never actually store the area. It will always compute it and return the result. Okay? So let's just run this once. I've also introduced a new trait here. This is again useful. This is a range trait. The first argument, I'm relying on positional arguments here. The first argument, you could also specify keyword arguments, is low value. The next argument is the high value. And the third argument, optionally, is the actual value of that trait, the initial value. Okay, so you can use the keyword arguments for better readability. But the range is, again, very useful, especially in scientific apps where you want a slider. So the typical UI element you'll get for this is a slider. So it's useful. And here I've declared this area as a property, and the property is also having a type constraint. It's going to be a floating point. Okay? And in this case, it only has a get. It doesn't have a set. You can also do a underscore set area, and that will be a setter for that property. So this is the same as Python properties, but I think traits properties predate the Python properties. But anyway, so let's run this. And now if I were to do this, it will compute the area. If I run it again, it's going to compute area every time. So the problem here is, even though it's nice to have this property, it's going to keep computing it every time you change. Even if you don't change the radius, right, it's computing. So if you really want, if the computation matters and it takes a lot of time, you can use this cached property decorator. And now let's see what happens. So if I were to do this, It's going to do that. And now notice that it didn't recompute the area. It just gave me the same value. So the cached property basically does the caching, and the magic happens here. The area, when you say observe equal to radius, again, this has the same syntax, the same syntax as the observe decorator. So you could have a list of traits there, or a comma separated set of traits, and it will honor those. So in any of those change, it will automatically update the area for you. So let's try that. So if I were to now say, now notice it recomputed it. Whereas if I were to try it again, it will not recompute it. So this is very useful, especially for long running computations. So if you have something that's a property, you don't want to recompute it, you can just use cache property. And again, the traits takes care of how to cache it, what to do, all of that stuff. It's taken care of for you. All right, so what's the next one? So the next one is the array trait. So now we're getting to more sciencey things like ranges and arrays. So this can handle arrays. So if you want to declare something as an NumPy array, you can use the array trait. It allows you to specify a D type. It also allows you to specify a shape. If you don't specify those, it's unconstrained. You can do whatever. But if you specify those, it will require that you have NumPy arrays of this. The one thing to be careful about with NumPy arrays is, unlike lists where you can listen to changes inside a list, you cannot listen to changes inside a NumPy array because it does not make sense. NumPy does not support that. And it would in fact be very inefficient if you had to listen to everything changing inside a NumPy array. So that's one thing you need to keep in mind. But otherwise, it's a very useful trait. So here's a simple example which demonstrates the phenomenon of beats. So you have two frequencies. It's just the NP sign of this frequency plus that frequency, so you can plot it if you want. So once you learn how to build a UI, in principle, you could just take this and add a little view and make a matplotlib plot. So when you change the frequencies, you can actually see it updating. That's an exercise for home. But this simple toy example here basically walks you through how to set this up. So here is I'm showing you range in different incantations, low, high. Otherwise, you use the explicit keyword arguments. Okay? Just building on the previous range that I used. And here, the array here I'm saying is I'm constraining it to be a float array. And I'm saying that the dimensions here, by saying none comma, this tuple, saying it's a one-dimensional NumPy array. Okay, it will not allow you to specify a two-dimensional NumPy array. And that's it. And now notice the syntax for observing two trait changes. So you say F1 or F2. Neither of these two change, it will update this self.sig. And yeah, that's it. So it works. So again, if you notice, with 10 lines of code, we have fairly complex, not really very complex, but we have an object model which has a kind of very nice behavior. You change F, it'll update. You change F2, it'll update. And now, and we can listen to changes. So, and everything is nicely, cleanly specified. And as you read this code, it's not very hard to read, right? You kind of know everything that's explicitly specified. You know all the types of all of the things. So it's nice. Okay, how much more do we have? Okay. So one thing that sometimes may trip you up is, let's say you have an object and you have a trait, and you want the trait's default value to not be hard-coded, but you want it to be computed. So for example, if you have the date, you want the date default to be today's date, okay? Not hard-coded to the time the programmer wrote this, right? You want a default so that when somebody instantiates the object, it gives me that particular time. So if you have something like this, so date is also a trait. So this is again going to constrain you to date time objects. So now what you can do is you can say, if you define this magic method called _date_default, whenever this trait is accessed, it's not going to be called by default. So whenever someone asks for a date, this method will be called, and then it will be set to this default. So let's try this. Maybe. So I'm going to just do this now. Oh God, what did I do? Sorry. Just to prove the point that what is this? Okay. All right, so this is, right? Notice that this print default was never called because I didn't access it. But now if I were to say, okay, give me the age, it will be computed, sorry, date. Now it will be computed and it'll give me a, what? Sorry. Why am I doing this? Tired, okay. Notice that, okay, it was computed. And the next time you call it, it's not going to be changed. It's this, only the default value. When you ask for it for the first time, it will call this. So this kind of allows you to do delayed initialization of an object and allows you to do it in a lazy fashion, as in it'll only do it when you actually ask for it. Okay, so there are these nice features as well. And it's, as you can see, it's not a lot of code. And when you read it, it's kind of self-explanatory. That's the default. Okay, I think this is the last major concept that you're going to see. Why on earth is this guy doing this? But we're going to need this later. So this is what's called an event trait. So sometimes, let's say you have some object model and you want to say this thing changed, and you want to make this an event that other people can listen to. The point of this is that it's not a value that has any importance. It is just something that's an event, right? So the value has no meaning. It's just the fact that it changed. That's the important thing. So that's an event trait. So for example, here we have a data file, okay? And the data changed is an event. So which means if I have a data file whose data has changed, I want to fire this. And this may happen for various reasons, right? The file may exist, but you may have edited it for some reason. And then let's say you have a data reader. So what you want is, whenever the data changed in that data file, you want to fire the reader should do something. So what you can do here is, this data reader has an instance of this file, which is a data file instance. And you can observe file.dataChanged. So whenever the data changes for that file, it will do something, some computation. So this is a nice way to, it's a nice trait when you explicitly want to declare something as an event. So it's not like you have to define something as an integer and look for some specific values or anything like that. So the way you do it is you define an event trait and you can listen to that change for that event. Does that make sense? Any questions? Yeah.
The button doesn't hold a value, it just gets clicked and something
Happens when you do that.
The button doesn't have a value. Right?
So for example here, I keep doing this. And now when I fire this, it will say file data changed. Okay, so that it basically notifies this, and it's just purely an event. The actual value doesn't matter. Okay, so that brings us to the end of traits. Now you have an exercise.
The next few lines are essentially defining the detector, the face detector. So the details here don't matter. So all that matters here is that we have someone did all the hard work for us, and at the end of the day, we have access to something that can detect faces. After that, we are looping through the list of image paths that we defined earlier. We are using PIL to get hold of an image object. So this is an image object that is a PIL image object. After that, we're extracting some metadata from the image object. So this is just the EXIF data from the image. So if you haven't seen this already, these are things like details of the camera that was used, take the picture, what was the focal length, aperture, so details like that. Sometimes it even has GPS coordinates. Then we're using that detector object to detect faces. And again, the detail, the API here doesn't really matter. All that matters is that there is a detect multiscale method on the detector, which will find faces. And the first argument to that method is an array representation of the image. And then there are some keyword arguments, some other keyword arguments that control how the face detection algorithm works. Again, not super relevant. So that returns a list of faces. That method returns a list of faces. What we're doing here is updating the metadata dictionary with just the number of faces we found in that image, printing them. So that was sort of our algorithm for finding faces. After that, we're trying to visualize what we found. We are using matplotlib. plt.imshow simply plots the image in a matplotlib plot. And then the rest of the code is simply drawing some rectangles where faces were found. Again, details are not really important. All that matters here is that this is a way to just slap rectangles on wherever faces were detected. So to summarize, we have image paths. We're trying to extract an array representation of the image in that path. We're trying to detect where in that image faces are located, and then we're storing some image metadata. So does anyone have suggestions on if we were to build an image file model, what attributes could it have? What are sort of things in here that we could throw in that image file model? So if we had something like this. Any ideas? So think about stuff we're directly using in this script. So the size of the image, yes, it is important. But in this application, what we're just interested in is detecting faces. And to do that, we need to get hold of an array. Where do we find that array? How do we do that? Yeah, exactly. Anything else? What could we do once we have the file path? Remember, we need to bridge the gap to detect faces. What was that? Yeah, and then extract. So one thing we could do is just directly extract the array from that image. So this would be, for example, the RGB data in the array. Oops, not here. I was trying to do on syntax highlighting off, but okay. And so one more thing that we're interested in this application are these are some kind of metadata, and initially it could just contain the EXIF tags of the image. So one more thing that we like in here is the metadata. What behavior should this class have? Can you think of a method that this class could have that will allow us to get to what we're really looking for? We are trying to detect faces. something like that. Okay, so that's, let me write that skeleton here. I have already written that skeleton here. So try to come up with a traits model, so something that inherits from has strict traits. And we've already talked about this. This has traits model should have a file path attribute, metadata attribute, or metadata trait, data containing the RGB array. Oh, one more thing we could have in there is the list of faces found for an image. And then this model should have a detect faces method that returns a list of detected faces. So what we want you to do is choose appropriate trait types for each of these attributes. So as a hint, file path could be a file trait. Something else to think about is the model should be reactive. So if anyone goes in and changes the file path, the entire model should remain in sync. It should act as a collective whole. So metadata should not be out of sync with the file path. The metadata should always correspond to the file path of the image file. So you can either just work off of facedetect.py itself. That's totally fine too. What we do not want you to do is try to do any plotting in the model. So just think of this model as a collection of attributes and behavior. That's all we're trying to do. We really don't want to really visualize anything right now. Some hints, I think you've already seen this. This is how to extract RGB data from an image if you know its file path. And some sample images are available here. Are there any questions about the exercise? 10 minutes and then start. Maybe we'll code collectively. That's something. Democratic programming. That's something we could try. And as usual, we're happy to help you out if you get stuck. Just feel free to ask for help.
Know where to start.
Would it help if we had some traits examples up, stuff that we talked about already? Yeah.
Guys are using a code editor, it'd be super nice if your code editor had the right Python environment so that if you got trace, it's going to help you instead of having to type so much, you go through tab completion. So whatever you're using, slider, VS Code, and something, use your tutorial environment. Tell slider, VS Code to use that environment so that trace is in it, and your imports are going to come up quickly. You're going to be able to tab complete.
sure why it's not like taking the string or really anything when I do uppercase, like here.
Let me see. So string is not imported, I think.
Oh,
So yeah, just do from Traitlets API import. Although for that, a better trait would be the file trait. So that was introduced towards the end. Here.
okay, so
Yeah, so like so Traitlets API file. So
oh, I see. Okay,
yeah,
okay,
it
okay.
represents a file on disk.
Got it. That makes sense. Thanks.
I wish I had. Okay, 10 minutes are up.
Yeah, we have just 40 minutes to our 4:30 to the.
Yeah, we should. We start discussing a solution.
Yeah, I think we should. That's easy. Because I find that it's easier for them to say, okay, what are you thinking?
Okay. So one thing we could do here is sort of try to code this up live. So, okay, I can see. So the file path trait, like we talked about, represents the path of the image file on disk. So what better trait to capture that than the file trait, which once again represents a file on disk. The other attribute we wanted in there was a metadata dictionary. So initially, let's just let it be a dict trait, but we might want to come back and refine that when we try to make our model reactive. So I'm calling the RGB data inside the image file the data trait. And this is going to be a NumPy array. And finally, we had the list of faces. So that is going to be a list trait. Oh, is it not? Yeah. Okay. And then we wanted this class to have the ability to detect faces. So here, what I'm just going to do is simply copy code from our face detect script and just paste. No. better UX would be if I did this. Okay, that's better. Yes. So here I'm simply copying from, just populating this method from the script. These are actually our faces, so a better variable name here is faces. Okay, so now if you, oh, thank you. Okay, this should not error. Okay, yeah. So, but this isn't ready yet because this isn't reactive. The file path trait, well, first of all, we have not figured out how to compute metadata and data. And even if we did, there is no reactivity here. These traits could easily go out of sync.
Line 24 basis NP array image there should be.
Yes. Thank you. So this can be self.data. Perfect. So remember the notion of a property that we talked about earlier? So this is something that is computed from another trait. So here, we think the data trait, which is the RGB array, and the metadata trait, both could just be computed from knowing the file path. So let's make these property traits. And these depend on the file paths. So remember, whenever we define a property, we have to go in and define how to access it or how to get it. So the getter for metadata would be called _ get metadata. Yep. And once again, I'm just going to
You also need a fill.
okay. And then similarly for the RGB data array, we can define another getter.
It should return.
Yep. Thank you. So yeah, so a good sanity check. Oh, both of these are properties, and they depend on. So a good sanity check, if you've just to make sure you've done everything correctly, is to go back and look at your property and the things it depends on, or the trait you're observing, and make sure that is the only sort of dependence on self that shows up in the getter. So here in the getter, we're only depending on self.filepath, and that is indeed how we defined both of these traits. So we probably do not want to be going into disk and reopening files. So it'll be a good idea to cache these properties just so that we get that performance boost of not only recomputing these traits if the file path changes. And we can import that from here. PIL is weird because I think you need to do this. I am going to cheat for tags. Let's see what it does. Oh, what was that, Jonathan? There it is.
I think you need numpy.
Okay, we're pretty much there. I think the only thing missing is populating the list of faces, and we can just do that here whenever we detect faces. Okay, let's try this out. Okay, so it seems to be working. Let's see how many. It did not find any. Oh, because there you go. So I think there are 5. It detected 5 faces in there, and these are just. This is the sort of representation that this method returns. So this is a representation of a face returned by this method. There is a lot of improvement we could do here. We don't have to go in and appeal to this PIL image object every time. We can also check if this is the extension, the file extension of the image. But those are details. I think these broad brushstrokes should suffice for an initial model. Are there any questions? Who has questions?
Can you scroll down a bit?
Oh, yeah, for sure.
Have you pushed this solution?
Yes. So a full-fledged solution is in stage 2.1/traded face detect.
So just a question/comment.
Mhm.
Perhaps it makes sense to have faces also as a property?
Yeah, I agree. But then things would have been really boring. Yes, it is sort of the nature of the object here, because it literally represents a file. Everything just ends up depending on a file. And yeah, I actually agree. But that has little pedagogical value. So. Any questions, any trouble finding the solution? I have it up on the right-hand side. So it's right here. Okay, so that model represents an image file. So another model we'll need later on is in our application is that of a collection of image files. So think of a directory containing several image files. So what I'm going to show you next is a model for an image folder. So once again, this is a traits model. It represents a directory containing several image files. And so because this thing is a directory, the first trait in here is just that. This is a directory trait, which represents a directory trait type, which represents the directories on disk. Here, I'm just setting its default value to the home directory. Because this directory is expected to contain a list of image files, the next trait is just that. It's a list, and each element of that list is an element of the image file model that we just came up with together. And then the final trait in here is a Pandas data frame. And the idea here is to collect the metadata from each image file and then just throw it together into a data frame. Just so that we have a collection of just so that we can look at the metadata for each image in one place. Another thing I'd like to point out here is simple validation that we're performing on the directory that is specified when this object is instantiated. So what we're checking here is whether this is a valid directory or not. Does it exist on disk? And if it does not, we raise a value error and sort of just throw up our hands and say we cannot go any further. If we do succeed, we just end up setting calling a helper method to create this metadata dictionary, metadata data frame using this helper method. And once again, we want our model to be reactive. So whenever the directory is changed, we want the list of images to correspond to that. So here, we're using the observe decorator and listening to the directory trait. And whenever a directory is changed, we just go in, look inside that directory, and create and populate our list of images to be image file objects. Again, this is a place where cached properties would have worked, but this is just, I want to try something different. Finally, so if in the images traits, in the images trait, remember that is a list of image file objects. So if either the images trait as a whole is changed, or if any one of its elements is swapped out with a different image file, we want the data frame to stay in sync with those list of images. We want that collection of metadata to remain true to what's actually inside images. So anytime that happens, we go in and update metadata. So this is just another model to help you think about and reason about these things, about traits a little better. And we'll be using these to build our applications in pretty soon. I think next. So first of all, were there any questions about everything we talked about? If not, what we'll do next is learn how to build graphical user interfaces with Traits UI.
Okay, so now the fun begins. And actually, Siddhant will do the more fun things. I'll probably set up the basics. Okay, so I'm going to kind of hard pressed for time. So I'm going to be doing this fast, so maybe you can slow me down if I'm going too fast. Okay, we've said enough about Traits UI, so we'll just jump right in. So the approach that Traits UI takes is not for you to have to write the UI code directly, but for you to just say what you want to be done, and it will do the rest for you. So it's called declarative approach to building user interfaces. And this also facilitates this model view controller design pattern that we're going to be using. And the idea here is the following. So you noticed what he did in his little the image file and image folder example. While it may not seem like he's done much, it's like just putting things together into a class. It's actually in terms of the model of what is going on, it makes it much easier, right? You can think of it as, okay, here's an image folder, and here's an image file. And the image file is like this object now that has this rich set of behavior. You set the file path, and it immediately updates a bunch of things. And so now you can build these rich objects with code that sort of mimics a specific behavior that you're looking at. That's hopefully easy to read. So this is called a model. And the nice thing with this is, so if you look at any of the code that was just discussed, it's actually easy to write a test case for any of these because it's just an object, right? You can just create an image file, put a sample image file, create a test, and then quickly write this and do that. So it's a model that basically manages data and state and has a bunch of traits that are convenient for a user. So so you focus on building those set of models, and the idea is once you have that, you already have the basics of a nice application. And now you can add a view to say, okay, for each of these objects, I'd like to specify how it should be visualized, and that's where Traits UI steps in. I'm skipping the controller part. It's not relevant at this point, but there is a way to actually put in a controller as well, but we're not going to cover it here. Yeah, so basically, model has strict traits objects. The views are all Traits UI view classes, instances of that. We're not going to talk about the controller at this point. All right, so let's start with our little silly examples again. So we have traits.api, bunch of traits, and we have a person with name, age, handedness, and whether the person drinks or not. Okay, so we have a little UI, and we have our favorite Star Trek person, Worf. Not my favorite, but okay, somebody from Star Trek. And there we have a little UI. So now this is the default user interface that Traits UI gives us. Okay, so when you do edit traits, it inspects the object, looks at all the metadata that's available in the traits, and then decides for you a UI and makes that up for you and pops this up. Now, obviously, you may want to configure this. You may want to change things. So that's where we get to specifying a view. So the first entry point into this is to learn how to specify a view. So the first line here is simply an import, which says from traitsui.api, import two things, item and view. So an item basically represents a single trait that you want visualized on the UI. Okay. So here we're saying view 1 is view, and it has a bunch of positional arguments saying item, 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 item. And each of these items has a rich syntax. So we'll walk through this. The simplest is just item, name equal to age. This name refers to a trait on the object for which this is a view. Okay, so our object has the following traits. It has name, age, handedness, and drinks. Okay, and which is exactly all of these names. So these correspond to trait names. The second slightly more complicated example here is item name. There's a style keyword argument. So usually the most common usage of this is style is custom, is something that you're going to see often. But I've just illustrated read-only. So what this is saying is, I want to see this element, but it's a read-only element. It should not be something the user can change, okay, on the UI. So that's a read-only. Custom is used when you want a customized editor. You don't want just the default. You want some special purpose editor. There are different kinds of editors. There's a simple editor and there's a custom editor. The default is, I think, the simple editor. If you say custom, it'll give you a slightly better editor. You can do further customizations by specifying what's called an editor. We'll come to that soon. Item, the handedness is also straightforward, no additional keyword arguments. But this one's a cool one. So when you want to say a person drinks or not, well, it's irrelevant if the person has an age that's less than 18. I don't know, what's the drinking age? Oh, I'm sorry. We'll change this to 21. In India, I think it's 18. Okay, 21, fine. I'll come to India and drink, so okay. So, so now you notice this has a specific UI, and the ordering of this matters. So the name is first, age is second, handedness then, and then drinks comes at the bottom. So you can control that. And now notice that if I made this 20, oh yeah, oh sorry, I'm still in India. Okay, 22. Okay, notice that the drinks popped up. So this is a really nice feature, which is you can make things visible when disabled or enabled when these are things that you can do. So there are a bunch of these nice attributes. So you can look at the documentation for the item and you can learn more about this. But I just want to quickly show you that. So this is what we mean by a declarative UI. I have not really said anything about what widget to use, whether there's no Qt code. I'm just saying I want this view and I want these elements. That's the thing. So you're specifying behavior, what I want, and the system figures it out and makes something. So there are many other attributes. There's something called label. So if you notice the previous example, so this one here is the label. And notice that it takes the name of the trait, capitalizes it, and puts it there. Now, if I had a trait which has underscores, it'll put a space instead of showing the underscore. So it does some default mangling of the trait name to make it look pretty on the interface. But if you want a custom name, you don't want the same name that the trait has, you want to put something else, you can say label, and it'll do that. Some cases, you don't want to show a label. You just want to show the editor for whatever reason. We'll find out very soon. So if you have very specialized editors, like you want a plot, you have a plot and you want to show a plot, you don't want to say plot or whatever that thing is, right? You want to see the actual plot. So in those cases, you can say show label false, and it will not show you the label. You can provide a tooltip or a help attribute, and you can specify something there. And when you hover over that widget, it will show you help. You can actually specify an explicit editor. So let's say you have a matplotlib plotting widget, which we're going to show you very soon. It has a specific editor. So you can create a trait as an instance of a matplotlib plot or patches or whatever it is, or a figure or whatever, and then say the editor is going to be an Mpl matplotlib editor, and it will use that for you. A style usually is simple, custom text or read-only. So if you say text, you'll just get a text box. And then enabled when, visible when, defined when. I've shown you a simple example. You can also make these items resizable so that if you resize the window, whether the widget should resize itself or not. Now that you have items, you may want to, now once you start putting these items together, you may want to start grouping these items. You want to say, okay, this is a group that manages, say, name of a person and personal details. This may have some employment details. So you can put together these items in groups, and you can do a bunch of additional attributes to those. You can configure them using columns. So if you want to lay out these things in 2 columns, 3 columns, you can use columns. You can specify a label for a group so that when it places it on the UI, it will actually show you those labels. You can lay it out in different ways, horizontal, vertical, stuff like that. You can show a border for a group. And again, you can define these, a whole group itself can be visible when some trait is greater than 15 or something like that. Okay. All right. So now in the previous example, what I did was the following. I had a view that was removed from the person class. Okay. So I had a separate view, and I just bound those two together by saying edit traits with that view. I'm lazy, and sometimes I prefer to just put everything in one place. So one common pattern you'll see with Traits UI code is people will write a class which has stick traits, and they'll stick a traits view right here, which just has the view defined. So a default view comes along with the class. Some purists will not like this because they would like to purely separate out the model from the view. But given that this is really a declarative way of saying this is what the view should look like, and you can customize this anyways, a lot of people will tend to do this. So if you want to, you can do this. So now if I just did this, I would get this UI that's defined here. So when you define a view like this, Traits UI will not go and find and come up with its own. It will use this particular view. So if you define a view like you defined any of the other traits, that is the view that will be used for that object. Okay. So the view itself has a bunch of additional keyword arguments. It can be docked, which means if you have like multiple views, you can actually drag them, drop them, and place them in certain contexts. So supposing you have multiple views, you have multiple objects, you can place them together in a tabbed view, for example, using this dock tabbed option. You can specify a height, you can give it an icon, you can specify whether the view is allowed to resize or not allowed. You can give it a title, and the title will basically give you a window title for that. And you can also do this buttons thing, which is you can specify whether you want an OK button or a cancel button or a revert button. There are some standard set of buttons that are available. I'll just show you a quick demonstration of that. You can also do key bindings. And this is something we're not going to talk about, but you can read the documentation for more. So here's a simple example that demonstrates the OK button and the cancel button. So everything else is the same. This is not a person that likes queso. It's not about whether they drink or not. Okay, this is fine. And now the buttons is basically going to use the OK button and the cancel button from Traits UI. So when you do that, so let's run this. And in contrast, let me run the previous one. Notice that this has no buttons. There's no OK, no cancel. Whereas if we run this, you will have an OK and a cancel. And it actually does, it's not just a silly button sitting there. If you change some traits and then you hit cancel, it will actually undo those changes. If you say OK, it will retain those changes. So there's something that comes for free when you just turn on those buttons. So I'm not going to demonstrate that, but you can try it out yourself. But yeah, so this basically shows you that you can now create models. And now with just this declarative way, you can put together a user interface, a very simple user interface. Okay, so I think you want to go now, right? I think maybe you can just take over from here, right? Okay. So now Siddhant is going to talk about more fancy editors, and that's where the real fun begins. So he's going to do plots, he's going to do data frame editors and stuff like that. So, sorry. But any questions until the time he sets up? So is the general approach clear? Basically have a model, and then it's just declarative things that describe how we want to see it. Yes? Sorry, can you make custom components? In what sense do you mean custom? Like, you don't want to drop down, you want some. Oh, yes, yes. So you will have to create your own editors. You can do it. He's not going to talk about that. He's going to talk about fancier editors that are available. He's not going to talk about how to create one of your own.
No.
Because that now will go, so that's where the Qt or the WX Python comes in. So the instant you want to go there, you need to basically expose lower level stuff. So we're only going to talk about the ones that are available, but the rest of that, you can find out that the example that he has now, Matplotlib editor, for example, if you read the code, you'll kind of see how he does it.
Okay, so the plan is to talk about some interesting editors. So editor is just something, no problem, that lets you interact with one of these traits here. So it'll show you a widget or something that the user can play with to interact with that trait. So one powerful editor is an instance editor, which, as the name suggests, just lets you edit the instance assigned to a particular trait. So here, again, we have a person with the usual name, age, and handedness, but they have a BFF, who is another person. Note how we defined, how we expressed that BFF is another person. We haven't defined this class yet, so we can't just go in and type person without quotes. So this is an indirect way of saying we want the same thing that we are defining here. Okay, so because this is an instance trait, this says that BFF is an instance of a person. When you create an item for it in this view, oops, did not mean to do that. This view will use the instance editor by default. And let me show you what that does. Okay, so we will create some Lord of the Rings characters. And so this, the real power of this editor is that, so obviously we have the main person, which this object is describing, and that is Sam, yes. And Sam's BFF is Frodo, and you'll see that a view for Frodo is nested inside the view for Sam. So the real power of this editor is that it lets you create these nested views with just the tiniest amount of code. Any questions about this? Perfect. Okay, so I think we don't really need this, so maybe. Yeah, okay. So it is also possible to configure the view used by the instance editor. So here we are defining explicitly what the view for the BFF should look like. And we added a label here. What else?
The idea here is you don't want see the BFF's BFF, and then that BFF, so that will sit and embed all of those BFFs. So you just want to say, okay, I don't want to see that. You can customize it. In this case, it's unfortunate. So the syntax here is just.
Yeah, so here you explicitly create an instance editor and pass it the view that you want to use for that nested instance. So we'll just go through that example one more time. Yeah, and
Also, I did show you these files.
okay. So we as scientists do a lot of data science at times, and the most commonly used objects used to hold data or a data container is a data frame. So Traits UI also has an editor that lets you interact with Pandas data frames. It's very simply called Data Frame Editor, although it needs to be imported not from the API, but from a special location in a special module. That has to do with Pandas being an optional dependency. We don't want Traits UI to depend on Pandas, so it's in a special place. Anyways, so here we have a traits model, which has, once again, a data trait, which is an instance of a data frame. And this is just a default value for that data frame. So what I wanted to do here was we'll come to model views in just a second. Okay. So here, we're creating a view for this data frame instance. And we're saying, hey, I want to use the data frame editor to be able to interact with this data frame. And let's just look at let's just try it without editable first and see what happens. Okay, so we have, let me make it resizable. Okay, yeah, so right now it's just showing you the data frame as is. So you can view it, you can click around, but you can't do much other than that. So let's try this with the editable equals true keyword argument and see what happens. So now I should be able to go in and change these. That is a bug. Okay, I was able to change that. Unfortunately, this editor is pretty new, and as I found out pretty late last night, a lot of the keyword arguments aren't synced up correctly. So it's a little buggy, but it gets the job done. Okay, finally, probably the most another really powerful editor is the Mpl Figure Editor, and this allows you to interact with matplotlib.figure.figure instances. So this isn't a part of Traits UI yet. We've sort of bundled this with the ETS tutorial, the repository, but the plan is to contribute this to Traits UI pretty soon. Okay, yeah. So to illustrate the matplotlib figure editor, we have a very simple class called image viewer. Actually, this will look pretty similar to the image file model that we just developed, and that's on purpose. So the data for this, the first trait in this class is called data, and it holds a NumPy array. Next, we have a trait called figure, which is an instance of a matplotlib figure. So this is the thing that we want to show our users and for them to be able to interact with it. And the view for this object is simply is for figure, and the editor that we'll use to interact with it is the Mpl Figure Editor. And once again, we just want to see the figure. We don't want to see its label. So we're asking Traits UI to not show us the label for that item. The data, the NumPy array by default contains a picture of Chelsea the cat, and this is a default value for the figure trait. So we are instantiating a figure object. We are creating some axes in it, calling axes.imshow, the usual matplotlib behavior that you should be, I guess which is really popular. And then it's the usual edit traits. So there is Chelsea the cat. This editor actually allows you to interact with this, with the figure object, just as if you had called plt.show. Or in fact, it's exactly the same as the behavior that we had with scripts, with that initial script without Traits UI. So we can zoom. It's as if we were just interacting with plain matplotlib. Okay. So as Prabhu alluded to, it's usually a good idea to keep your models and views separate. And that has, so we'll keep on harping about this because this is important. It aids testing. If we don't have a UI in there, we don't have to set up you don't have to do complicated things just to test, just to get that instance up and running. So the complication arises from event loops and testing and event loops. It's not a road we want to go down. And it generally promotes better reuse of your code. So if you just have a model without a UI, you can interact with that model in different ways. Maybe you can wrap it in a web API. Maybe you can have two different UIs for the same piece of model, which you show to different kinds of users. Maybe an advanced scientist and then someone who just has a working knowledge of science. So with that in mind, so that suggests we have this image viewer class with some data in it. And because we want to keep our science logic separate from UI concerns, that suggests maybe we should just rip out this this visualization or GUI related code from outside of this class. But where would that go is sort of the next natural question. So although we want to split our models and views, we also want sort of some interactivity between the two. We want our view to be able to respond to changes to our model, and our model to be able to sort of be able to tell what's going on in our views, if not in the model. And an object that lets you do that in Traits UI is a model view. And so let me show you what that looks like. So here we have a simple image class which does not have any GUI related code. So I've ripped everything out. Instead, I've created this new image view class. This is a wrapper around our model. Hence, the first trait in here says that our model is an instance of image. And then it has all the GUI related concerns in here. So this sort of allows us to do kill two birds with one stone. It allowed us to rip out all the GUI code from outside of our model so that we can reuse it. And then at the same time, we can have this reactivity between our models and our views. So as an example here, we are saying, hey, listen to changes to the model trait or the data attribute of model. And if either one of these changes, go back in and rebuild my figure, because that makes sense. If the data has changed inside the model, then we need to update our figure. So something to notice about model view classes is that the model trait name is special in that it always points to the thing that it's a view for. So always make sure you follow that convention because this model trait is hooked up to other things inside Traits UI. So this is also, once again, a very simple example. Model views do a lot of other stuff. They listen to, for example, changes to the first time a window is created, whether the user is clicking on the OK or cancel button. But those are sort of out of scope for this tutorial. But in any non-trivial UI, you might have to hook into that functionality, and model views are an entry point to do that. And the way we would use model views are pretty simple. We first instantiate our image model. Then we go back in and say, create a view for me as an instance of the image view class, and the model in here is this object we just created. And now I'm going to edit traits on the image view objects. So that is Chelsea the cat again. And remember, we had this observer hooked in, which listens to changes to the data trait of the model. So if I go in and change the data trait of the image to be the sample astronaut image, hopefully. Yeah, so that all of that happened automatically and was taken care of by this functionality right here. Any questions, concerns? Yeah.
So when we popping up this class, and it looks like a normal Matplotlib window, but it is not. The only thing that shows you that it is not is at the top, the window says edit properly, so I can't remember what it says, right? So even though it seems like this is a very complicated way of making a Matplotlib plot, it is a much more powerful way of showing a Matplotlib plot because you can show any number of widgets around it, and now you have a full application. So I just wanted you guys to notice the border around the Matplotlib plot and realize that we are actually already building a scientific application.
Okay, so let me walk you through. So we came up with the image file and image folder models earlier. So let me walk you through what model views for those two objects would look like. And if you want to follow along, this is in stage 3.1. This should be the only file in there. Yes, so there are 2 files in there, 3 files in there. So the first one is traded face detect. So we have the, let me close everything else. So we had the image file model, whose traits are file path, metadata, data which contains the RGB array, and then a list of faces. The model view for that looks something like this. So remember, the model trait is special in that it points to what this is a view for. So this is a view, this is a model view for an image file. So that is specified here. And then we have some GUI related code here. So we are saying we will present to the user. So we will use a matplotlib figure and present it to the user. So the figure trait is just an instance of matplotlib figure. And then in the view, the first thing we are presenting is the file path of the image file. And then the second thing in here is the figure. And for that, we're using the Mpl Figure Editor, just like we talked about. And then there are some buttons in here. And then the title of our application is PyCasa. Here we are hooking up an observer which listens to changes to model or file path. And this just builds this figure instance out. So what it'll do is, if file path is bad in some way, it'll just return. Otherwise, it'll create a new instance of figure, add axes, show the RGB array. And then, so this is interesting. Here it's calling detect faces on the image file, which compiles the list of faces inside the image. And then it's adding rectangles corresponding to each of those faces to the axis. Yeah, so hence the figure. And then it updates self.figure to be figure. So if we want to see this in action, in terms of behavior, this will feel very similar to the original script, but we've done something very powerful. We've pulled out models. We've teased apart the models and the views from that script that we had. And that'll allow us to extend it even further and embed them, sort of craft a full-fledged application around them. Oh, okay. So what we're going to do here is select. So this is model.filepath. It was empty initially, so now we have an opportunity to set it. So if you want to, let's compare this to the view that we defined. So on the top, we have model.filepath, and this is something that we were actually able to interact with and modify. And then we have the rest of the figure with the faces detected. And I'm sure we can do this any number of times. I doubt if this has. Ooh, okay. I think this is a screenshot. Yeah. Okay. That is all I wanted to say for this. We define another class, so maybe it'll help to open them up side by side. This one is pretty simple. So the image folder, remember, was a collection of images in a directory. And the first trait was the directory trait. So in the image folder view, we start off again by saying, hey, this is the view for an image folder. So we set the model trait to be image folder. The first UI element in here is the directory on the image folder. But here we're using a read-only style, so we won't be able to interact with it. And then the second item in here is model.data, which recall was a data frame containing metadata for all the images in that directory. So one interesting thing we've done here is we're saying, hey, only display this data frame if the size of the data frame is non-zero. If size of the data frame is exactly 0, then show this helpful error message saying no images have been found. No need to concern. I think so. What Spring does is it's just stretchy space. It'll just fill out. It's just to create some padding between the top and the bottom. Okay, so it is quite small, but this is the view for this directory, and it's showing us a data frame representation of the metadata for all the images in that directory. And then had I changed this to something that does not have any images. Oh, it does have an image. Anyways, I think we're running behind, so I'm going to skip demonstrating the no images found. You'll see that soon enough when this is in an application, hopefully. Okay, any questions?
We're going to start slowly. So all right, let's get started. So we've gone so far in the first in these two first sections. We've gone so far to stage 3 of this application, and we have 8 stages. So thank God it's an 8-hour tutorial. Because otherwise it'd be tough. So in all seriousness, we're not going to be able to get all the way to the end, but the end is provided to you guys in the GitHub repository, and not only that, but we're giving you many stages along the way. So we're going to go a little bit further. I really want to introduce PyFace, in particular because. So Prabhu mentioned the ETS documentation for traits is really good, for traits UI is really good, but for PyFace, it's not as good. And so I feel like PyFace is one of these packages that's out there that really, actually, I should take this off, that really could benefit from being understood a little bit better, being presented a little bit. And what I'm showing you guys here is stage 6 of the application. Really, 7 and 8 is are details. 6 is already really fully featured, and even before that. And so if you guys look at stage 6, you see a few things that we haven't introduced yet. We haven't taught you guys how to do a few things. But even though it doesn't look all that impressive, it is a decent application already. You have a browsing pane on the side. You can double click on an image. You can click on a button, and it's going to detect the faces, and then it's going to draw those faces after the fact. What else do I have in here that we haven't introduced? I have little messages at the bottom. This bottom piece here, it's called a status bar, right? So it adds a little bit to it. It has some toolbars at the top. We just put a couple just to illustrate the concept, right? We're not trying to build something that's actually useful to anybody. We're just trying to teach you guys. And then, so this is a Mac, right? But so the menu is up there, but you can also see that there are some menu items, right? So this last phase of the tutorial, we want to introduce, and we're just going to dip our toes into it. We want to introduce PyFace and kind of the framework that it provides to compose all these views that you guys are now hopefully feeling capable of building, right? We know it's a lot of information, but you are capable of building views. You can define a view, you can put some items, and so now PyFace is just providing this framework to embed those views and make the application a little more scalable, really, because a Traits UI view, you can add more and more things, but it's not going to scale great. Yeah, we've introduced the instance editor, so you could do some composition, right? You could define multiple views and put them together in a Traits UI view, but that would only take you so far. And based on my experience and Prabhu's experience and Siddhant's experience, if you guys want to build something of a little bit larger scale, getting comfortable with PyFace would be super valuable. Okay, so that's why we're going to dip our toes into for the last few, for the remaining 25 minutes. Okay, so apologies. We at the end of the preparation for this tutorial, we were working in parallel. So we have a deck that is in Markdown that was in the slides folder, and then the PyFace deck, I was building it in Google Slides, and so you have it. You have these slides as well as a PDF inside the docs folder of the repository. So you have all of these slides and actually many more. And we're going to continue to work on merging things so that it's a little bit more unified, but it's not going to prevent us from having a good conversation. All right, so I want to come back to a point that we made at the very beginning of this tutorial about what is really my favorite thing about ETS, the Enthought Tool Suite. The reason I like it so much is because you can learn traits and build models that react to themselves, and you're already infinitely more powerful than before learning traits. And then you can learn Traits UI, a little bit of Traits UI, and all of a sudden you can pop up a GUI in 3 lines of code, which is going to blow a lot of people's mind that are not used to knowing how to do this that simply, okay? And you can continue this. This is a long journey that allows you to build applications that are smarter and smarter and more complete. And we're going to show you guys in this last piece the next layer of the onion. So if you wanted to build a very small application or a fairly small application, I'll let you guys define what that means, then Traits UI is good enough. You can put a little widgets, you can put some sliders, you can put a matplotlib plot or anything else, a data frame. Now you guys know how to display a data frame. Like there are a million, an infinite number of ways to build data frames, load them from something. So you already have tools to build an application of fairly simple scope. If you were to build something a little bit larger, then the recommendation is to use PyFace. We're diving into that. And then if you wanted to build something even larger, something that had lots of different components that should be defined, potentially different code bases and so on, then the largest piece of the onion is called Envisage. It allows you to define plugins and continue to compose. And again, what I want to insist on is the fact that you can start with just traits, and then one day you have time to build a traits UI panel for it, and then you are the king of the hill. And then one day you don't have to throw anything away for that, right? And then the PyFace layer is the same. You can build traits UI panels, and then you don't have to throw them away to put them into a PyFace framework, and all of a sudden you have an application that's even larger and more scalable. And then if you did that, you define those tasks. We're going to do that together. And then one day your application continues to grow. Then you're like, okay, I'm just going to reuse all of these tasks and things. I'm just going to put them in Envisage. And now I have a larger and even more scalable application. So that's what some frameworks, you have this very steep starting point, or you have this very slow starting point, but then at some point you have to throw everything away and do it again, right? And what I love about ETS is that it gives you the ability not to have to face that. You start and you stop wherever you need, okay? So these are the three frameworks. Sorry, I just spoke, but this is summarized in this slide. ETS is going to provide to you these three frameworks. You've learned about Traits UI, you've learned about PyFace, and then you can know, or you will learn about PyFace a little bit, and then you can know that there is yet another framework if you need it to continue to grow. All right, so what is PyFace? PyFace is multiple things. It is this layer, this traded layer between Traits UI and Qt, right? So it contains some of the guts that allows Traits UI to work. Some of the secret sauce it's all open source, so it's not nothing is secret there, but. So it is this layer, but what I want to focus on, so it's a few things. It's even a few things that are now deprecated, like the workbench. It provides native dialogues, and so that's another thing you could go and explore. I'm going to skip that slide, and I'm going to focus on this item number 2 here, which is this task framework. So allow me to focus on that. So here I have a slide about the little PyFace dialogues. They look nice. They look nicer than some of the Traits UI dialogues, but because they directly use the operating systems dialogue instead of painting things with Qt. So they look nice. You may want to take a look into those. But what I want to present is the task application framework, because now you're going to recognize some of these components that we wanted to get to with the final application, right? So in the final application, I have this tree on the side, but one thing I didn't show, one thing I like about this application, and you saw the little splash screen too. That's in stage 6, but it's that these are panes that can move around. So it's not only a GUI, but it's a customizable GUI. So that's one of the things that this task framework is providing for us. It's defining this central piece, and then you can define any number of panels around. You can even close them and bring them back. You can undock them. So I like this when I need to build a product. I like to provide people with a framework where they can customize their views, because the scientists I work with, they have complicated lives. They have lots of information that they want to see, and maybe lots of information that they want to be able to hide. Okay, so that's one thing that this task application framework is offering. So so here it is. So this framework is providing 4 different levels of responsibilities. Okay, so I'm going to start, I guess, 5 with the model. So I'm gonna start with the 2 layers that you guys are already familiar with, right? The models, and we won't say enough how important it was the beginning of this tutorial, where you guys learn to define your models and make them responsive and make them never be out of sync. So the model is holding the truth, right? So I'm at the I'm at the innermost circle in this picture. And then around it, we have these model views. Now you guys have seen an example of building a view for your model. So you give it the model, and then you start drawing it up. And if you build an application, a realistic application, you'll have multiple models. You'll have a view for each of them. And then these are, for now, disjointed views. So around that, the task framework is providing one concept to embed those views together if you need to, and it's called a pane. And what I just dragged around, that was a pane. Okay, so a pane can be dockable or undocked, can be hidden or brought back, and then it can contain multiple views if need be. Okay, so that's the pane. Here, for example, I have 2 side panes. They are called dock panes. And then I have the central pane here, the central area. So I have 3 panes in here. And then there is the level of responsibility above the pane in this framework is called a task. And a task is supporting this entire window. So a window is made of these 3 panes in this example. This is an actual product I built at KBI, by the way. And so this task is responsible for supporting the entire window. And then an application might launch multiple windows. So I have all these levels of responsibilities. You can keep them very simple. I'm going to show you guys a hello world in that framework. But you have the ability that, again, I'm going to come back to that word scalable, right? If you are building something a little bit more complex than just a few sliders, it will be powerful. It will be useful for you to have these different layers that have different responsibilities. So let me repeat that. The application is responsible for just launching the tool and generating windows. A task is supporting one window and defining the panes for it. And then a pane is holding the model views and just displaying them and allowing you to dock them and so on. Any questions so far? You're good? All right, so let's do a hello world. We're going to start by the innermost level. That's the one you know the best, okay? So I'm defining a hello world has traits, and this is my model. So my model is going to be ridiculously simple, and it's just going to hold a string that says hello world, okay? And then what we've seen before, obviously nobody would be in their own mind building all this for just a hello world, right? So you have to imagine your own problems and your own models in all of these, right? So if it's complicated enough, you want to separate the view from it. So I created another class, and it's a model view. And so the model is an instance of my hello world. And then I'm defining a view for it in this model view class. I'm gonna take a short second here to mention that the view so far, we've been defining views directly inside the model view class. But another way that allows potentially for more complexity or more fanciness is to define the view in a dedicated method called traits view. All right, so I'm doing exactly the same as we were doing before. I'm just returning it from a method instead of just defining it directly on the class. These views can get complicated. You could imagine situations where, depending on a situation, you want to build one view or another. Okay, so if you are inside a method, you could start having some if statements. You could start having more complex things. So it's a good thing for you to know. And then at the application layer, at the application level, so there are two levels in between, the pane and the task. I'll come back to that in a second. But at the application level, the simplest thing that the application needs to do is to be created, and the run method on it is going to create this GUI event loop, the whole graphical user interface system to support your views, right? So that's the application that's going to do that. So I'm creating an application here called Hello World App. And this is going to be a subclass of PyFace's application. Okay, so Hello World App. And the minimum thing I need to do is I need to tell the application what windows it is capable of building or what task it's capable of building. Okay, so you guys have learned in the traits section that any object, any traits class, you can initialize any of its attribute with an underscore, the name of the trait, underscore default. So that's what I'm doing here. By default, if you create an application, directly a PyFace application, there are no task factories, so it doesn't know how to make any task. Of course, it's just a base class, right? So you know what window you want, and so you're going to say, in this case, for example, the simplest possible thing is to say, I just want a hello world task. And now we're going to define what it does. Okay, so I'm saying underscore task, underscore factories, underscore default. For task factories, it is an attribute that's defined in the parent class. And I'm overriding how to initialize it by giving it my own task. All right, so let's build that task. So to build a task, I'm going to I'm going to make a hello world task, and I'm going to inherit from the capital T task from PyFace. And I'm going to say, you're going to be the world's simplest task. You're only going to have a central pane. Okay, a task needs to have panes, at least one. And so you have to say, you have to define what that central pane is. If you only have one pane, it has to be the central pane. And then you're just going to return one type of pane. So I'm returning that pane, and obviously now I need to define what that is. Okay, sorry, the code is a little bit jumbled here. All right, so what is my pane going to do? It's just going to show my model view, and now we've linked the two sides of the code. Okay, I had a model view that was just displaying the model's message, hello, or hello world. And my pane, just like a model view, my pane is going to define its own view. So a pane's view might be, again, like I said earlier, it might be composed of multiple model views. In this case, again, I'm trying to do the simplest thing possible. So my pane only has one element, and it's showing that model view. Questions? Yeah.
you're training a list there to support multiple
Tasks.
why a list? Multiple tasks.
Yes. Yeah, you can imagine an application that's capable of opening. So in this example, I have multiple windows and they all look the same because I only have one type of window. But you could imagine an application that's, depending on the situation, bring you a dashboard for one thing or a dashboard for something else. So it's capable of knowing how to build, how to factor, be a factory for multiple types of windows. Great question. Any other question? There is one question. There is one question you guys might ask here is like this little parenthesis inside the instance trait is just forcing this model. If I don't specify a model, it will just make a default model. That's what the open close parenthesis does. It's a lazy way of saying just return just a hello world. Okay. All right. And so once I've built an application with all of these different layers, to run your application, you just make an app and you call run on it. And then everything else is taken care of. Okay. So let's look at this live. You guys all have that hello world example in your code, but I'm just going to run it in here. So let me close this one first. So this hello world example, we're giving it to you as stage 4, stage 4.0 actually. And because we're now building an application, we have splattered these different classes into their own files so that they can grow. So actually, before I run it, let me say one thing about refactoring code. So far we've been trying to keep everything simple by just putting everything in one file. But you can imagine that now if we have to create an application object, a task object, a pane object, some models, we already have a couple of models, right? We have an image file and we have an image folder. There's a couple models already. And then the views for each of them. So we're starting to have quite a few players. And so to not get lost with these players, the best course of action is to put each of these classes into their own modules, into their own files so that they can just live and grow happily. The other thing that's recommended when you get to that point of scalability is to even put things into sub-packages, right? We said we should separate models from views, so we can do that by even making subfolders. So that's what we're describing here and we're recommending. Again, once you get to that point, is let's make a proper package at this point. So we're going to have an application called PyCasa. So let's make a package called PyCasa. So that's the top level, the package name. And then within that package, we're going to have some different types of responsibilities. So we're breaking it up for you already that way. And we're providing it to you broken down so that it can provide a starting point for you guys in the future to build your own tools. Okay? It's not to make you suffer. It's to help. So, okay, so I have an application. The application should just be responsible for the app submodule, subfolder should just be responsible for creating an entry point into our application and defining an application object. So in app, we're gonna define the app, and we're gonna define the launcher for that app. Do you guys remember what code should be in the launcher? It's two lines of code, right? This is the launching code. So our main is going to be 2 lines of code. And then the application itself is 4 lines of code. Okay? And that's going to grow. All right. Then we have models. We've talked about models enough. We already had a couple earlier. We're gonna bring them back at stage 4.1. Well, we would if we had the time. So that's okay. And then the UI piece, sorry, time flies. The UI piece is where all of our model views are going to live. I/O, we don't have any I/O yet, but typically in an application, if you were to save your work or load your work, you would have some functions to learn how to do that. You would typically put it in I/O. And then you might have some tools, some computations that I typically like to put in tools. Utilities, you can offload them outside. Anyway, so here is an example. So I have that PyCasa application. Inside the PyCasa application, I have the app. So I said the app better be pretty darn simple. And so that's what it is. In the slide, I was a little bit more tight, so I didn't take the time to be do anything fancy. But if I was to define a name, for example, it will automatically give that name to the windows that I create. But anyway, I'm just creating some task factories, and then the main is going to be that simple. I promised it would be 2 lines of code, a little tiny bit more. We're importing that application and we're calling run on it. Okay? And then if I go into, if I go into UI, we're going to have a hello world view, same as in the slide, etc. Okay? So to be able to, now I have multiple files, I want to be able to import them. So I need a setup.py file. I don't know if you guys, I need to go back up. Hopefully you are familiar with setup.py files. Actually, this one could have been simplified even. But this is regular Python code. And again, it can be very simple. It could be just a couple lines of code, or not a couple, but very few. And this is just hello world. And then whatever, it might have a version or it might not have a version. And we're just defining, this is optional as well. Sorry, I'll clean it up. It should have been that simple. All right, so the setup.py is there to allow me to define a package. So once I have my Python environment activated, I can run setup.py develop, and now my PyCasa package can be imported from anywhere. And that allows me to run my main, which is going to import my app. My app is going to import my task is going to import my pane, and so on and so forth. All right. So if I now run, so which file should I run to be able to launch the tool? And we'll finish on that. Can you help me? Main, where is it? It was in the app folder. Very good. So that's starting the event loop and launching the tool. This is not hello world. I forgot to call. Anyway, we're out of time. I want to be respectful of your time. So anyway, something is being funny here. But anyway, we're gonna end on this. There is a lot more slides to explore. The hello world example can be morphed into the first PyCasa application, and that's stage 4.1, and then stage 5 and stage 6 are going to plug in all of the models and the model views that we created in the first phases. And then, so that's on stage 5. In stage 5, we also add the buttons to launch the detection of the faces. But all of that has been coded in those models. Okay, so now it's just a matter of connecting those things and displaying it within the application. And stage 6 is introducing how to create those menus and those toolbars. All right? Any final question? Thank you guys for surviving the whole 4 hours. Any questions? We're good? All right. Have a good evening. Oh, there is a get together at the Enthought headquarters on Cesar Chavez in 1 hour.